Welcome to the demonstration corner. Today we're going to talk about the newest addition to the measurement platform series, and that's the MPV. As you can see from our middle banner here, our MP series starts with our MP1, which is our advanced model of the measurement platform series. This has all the latest advancements in the transient plane source, transient hot wire, and a couple other methods. It's sort of the leader in the transient space on cutting edge technology. That's the apex of thermal physical properties by transient methods. And then we've always had for years our MP2, which is our portable measurement platform encompassing several sensors: transient plane source, transient hot wire, and transient line source. We encourage you to learn about those depending on which end of the measurement platform scale you are. We have lots of demonstration videos discussing those. So today, our new mid-range MPV, which the V stands for versatile, it combines a number of sensors that are in the basic package, and we'll talk about that, as well as the optional sensors that advance it or empower it to do more than what its basic design is. A little bit of background on the MPV. It's the evolution of the TPS-2, which was essentially a transient plane source only instrument. Why did we evolve it? Is our customers were asking for a mid-range instrument that also followed the ASTM for measuring liquids and added the capability of some of the more common methods for measuring soils and polymers and single-sided testing. These sensors are not new to us. We've been involved with these sensors for decades. We just brought them all together with, so technology we're very familiar with, brought them all together to form a mid-range thermal conductivity, thermal diffusivity, and specific heat method for solids, pastes, and powders. That's the transient plane source method, and liquids and phase change materials by the transient hot wire method. We've added MTPS, the absolute version of the MTPS sensor, MTPS standing for modified transient plane source. What makes something modified is when you change its original design or its classic approach. So the modification of our TPS sensor, making it a permanent single-sided sensor. We'll discuss more about that and its construction and what we've added to it to make it a very unique sensor in the thermal physical property space. And then the optional transient line source, which of course we've been involved with for a long time for measuring thermal conductivity of soil and polymers by ASTM 5334 and 5930. So to the other side of me is our MPV, and we'll be talking a little bit about this. So again, the controller itself is going to look like a TPS-2 because it in fact is. We've just added the capability inside of it and created a package that really creates a lot of versatility in the mid-range thermophysical instrument space. So the two methods that it combines are transient plane source following ISO 22007-2. The basic thermal conductivity range for that transient plane source is 0.01 to 100 watts per meter Kelvin. That's your basic range. That can be upgraded within the same controller up to 500 watts per meter Kelvin. So, but the basic package is up to 100 watts per meter Kelvin. It comes with, so that transient plane source method comes with 3 sensor sizes as the base package. So this is radius 3.2, 6.4, and 10 millimeters radius. That comes with the basic package. And none of our sensors require cables because all of our adapters and connectors for the room temperature sample holder are quick connect, so you don't need cables. So these sensors, of course, can go up to 300 degrees. It's just the adapter and cable that limits that. So the included sample holder and adapters go up to 80 degrees Celsius. That can be upgraded with an upgrade in the adapter up to 300 degrees Celsius. On the low side, all of our sensors and adapters can go to minus 75 Celsius. So again, for solids, pastes, and powders following transient plane source in the ISO, the basic package comes with 3 transient plane source diameters and what you see here. In addition to the bulk method, so in addition to measuring bulk thermophysical properties, we've included the slab module. So for the slab module, it allows you to measure symmetrically conductive sheets. So this would be for materials that are thin in nature in the range of 0.1 to 100 watts per meter Kelvin or 500 watts per meter Kelvin, depending on if you have the max power package. So again, the basic TPS package comes with bulk as well as the slab module. So included in that package is our transient hot wire sensor for ambient pressure. And as you can see, hopefully, there is a wire that is between the two contact points. That wire, the reason why this is a unique method for measuring fluids is that you don't get convective effects. So why don't you get convective effects is you have a small amount of area of that wire and short test times and low powers. So we still achieve optimum temperature rise, but we're ensuring through selection of those parameters that we're not getting convection effects. And that allows us to measure thermal conductivity, thermal diffusivity, and volumetric specific heat. And if you input density, you get specific heat for liquids and phase change materials according to ASTM 7896. So that creates a really powerful thermophysical properties for both solids and liquids and powders and paste, following the best suited method for each. And they're both absolute, so there's no calibration of each. They follow the ideal theory and produce very good results in this mid-range. Optional additions to the MPV transient plane source package are the specific heat cell. This, if you want to measure direct specific heat of your materials, we have demonstrations on this as well. So that's for measuring direct specific heat. That's quite convenient for measuring heterogeneous or anisotropic samples. We have the classic thin film for measuring thin films according to the ISO. And then the anisotropic module can be added to the same approach. This is Torlon. I'm showing this as a placeholder for what is a highly directional material. So the additional modules that you can add to it, again, are the anisotropic module, the thin film module, and the specific heat module. The slab module is included in the base package. So that's sort of the transient plane source and transient hot wire. And we have some optional sensors and upgrades that you can add to those. But before we go, I'll just get out of the way and talk a little bit about the controller, test time, and the software. So the MPV controller itself, it has variable test time, again following the ideal theory of transient plane source. It has a high, it leads the industry in detection of points, data points per second, as well as a Wheatstone bridge following the ISO. So it's really important that we've constructed a unit to follow the standards as they're written. So the software itself, we have the same software package. We've separated out the data acquisition and the analysis into two separate applications. The reason why is with the MP1 and the MPV, with the ability to measure a wide range of methods, it's a lot to pile into one application. There's a lot of data that it ends up clogging up one application and making the system less convenient to use. So by separating them, we have the most power in data acquisition to enable some really key features. And one of them is the iTransient. So I stands for intelligence. So we add it, we've been working on this for a number of years, which is the iTransient, which is full automation of parameters for all methods. So really all you need to do when you want to measure your materials is input the name, and if you're measuring a solid, input the dimensions of your solid. Everything else is fully automated. Again, following ideal theory, no calibration, no factory calibration either. All of this is done through the intelligent design element we've added to the data acquisition and the analysis, so it fits on both sides. So for transient plane source, you just enter your sample name and the dimensions, and for transient hot wire, you just enter the sample name and the software does everything else. Now, we've still left the ability to manually select parameters and manually analyze the data. We think that's really important because it fills the void of those that want deeper understanding. There are a number of high-level things one can do with even a mid-range instrument to really understand your materials at a very high level if you need to. So we've left that. That's really in the soul of all the instruments we make, is the ability to analyze the data manually if you want to do that. So let's turn the camera to the optional sensors and talk a little bit about those. So we've got a few things laid out here just to create a conversation, but the MTPS package is what you see here. So we packed a lot of power in what we offer as a modified transient plane source. And let me describe a little bit. So we've created a sensor that is convenient to use. Your sample can be placed on top, or your sensor placed on top of your sample. Now we include this cradle for a few reasons. One, it has silicone on the bottom for stick. Also, that creates vibrational isolation if you're making measurements in a lab that's a little bit vibration orientated, or inside of a furnace that has a little bit of vibration. So by including that, we create a nice foundation for making measurements if you're in that environment. We also, inside the cradle, lets us use this approach over the weight if that's needed. So you can, for measuring a sample, you can do it with a weight, or if you want to vary pressure or apply more pressure, you can use a standard knurled knob. And include it with the MTPS sensor is a powder cell. This is a simple click-on powder cell, or you can also use this for measuring paste. So again, the MTPS sensor, it follows the same thermal conductivity range as your MPV. So if you have the basic package, this goes from up to 100 watts per meter Kelvin, and if you have the max patch, this goes up to 500 watts per meter Kelvin. And that's the same for the modules. So again, your base package is a paste and powder cell, so you can measure solids, paste, and powders with this sensor. So what makes this even more powerful is the ability, rather, the inclusion of modules in with the sensor itself. So you're not buying them individually. We wanted to supply a sensor that allow you to measure a wide range of materials, both directionally and dimension and shape. So you have the inclusion of the bulk properties, which would measure three-dimensionally bulk thermal conductivity, thermal diffusivity, and volumetric specific heat. This would be an example. This is a verification material that comes with it. Again, you can configure it like that. So as this is an absolute method, so we've created the absolute version of the MTPS sensor. What does absolute mean? It means from the output of the instrument, we calculate the thermophysical properties. So you don't need a contact agent to normalize the contact. We remove that as per the traditional theory of the TPS sensor and method, and create a sensor that's convenient. So merges the ideal theory with a convenient sensor that is single-sided in design. And to pack as much punch in that, we added the additional modules in addition to bulk. So you have 1D. So this takes advantage of when you have a sample that's taller than it is bigger radially, this takes advantage of that direction to measure along the length of an elongated shape for thermal conductivity and thermal diffusivity. So it includes the 1D module as well as the slab module. Again, these are verification samples that come with the sensor. So that's the configuration for slab, and you already saw the configuration for 1D and bulk. Now, one thing you might realize is that these are all asymmetric configuration, and that's true. So these are all single-sided configuration for bulk, 1D for elongated shapes, and slab for measuring conductive sheets. Again, the range can be as low as 0.1 watt per meter Kelvin up to 100 or 500 watts per meter Kelvin, depending on the package you have in thermal conductivity range. And the last module that we've included in this is the anisotropic module for measuring directional properties. So you have the bulk, the ability to measure bulk materials, the ability to measure one-dimensional shapes, the ability to measure slab shapes or conductive sheets, and the ability to measure anisotropic materials. So for sure, in this package, for asymmetric testing, single-sided testing, there is an approach to measuring your materials. So we want to really create an MTPS sensor for today's market. And the two temperature ranges that are offered in the MTPS sensor are 100 degrees. So there's a 100-degree version, so minus 75 to 100. And then there's a 200-degree version, so minus 75 to 200 Celsius version. So that is the MTPS sensor. And of course, we're going to talk a little bit about its construction, and that's just a guard you can put over it to protect it. So I want to share a little on its construction because I do get asked the question, what is the difference between your MTPS sensor and what makes it follow the ideal theory, and what is the difference between that and what's on the market? So I thought we'd disassemble one and put it back together briefly just to show you that. So this is the body of the sensor itself, stainless steel with a wire. There's 4 contacts made that are soldered to the back side of these 4 contacts, just like a cabled TPS sensor. This is a classic double spiral. It's a little hard to see in this light, but that's a double spiral sensor with extra Kapton. And what we use the extra Kapton for is to sandwich around this insulation. So this is, we have different types of insulation depending on the temperature range, but once we sandwich that or wrap that around that insulation, we create tension on that by putting that layer of Kapton and sensor underneath that. That creates a tense sensor that you can clearly see here. So that creates a tense sensor, and you can see the double spiral there. And that allows us to make sensors that follow ideal theory and only use backing insulation. So because our classic configuration is either two-sided, where your sensor is sandwiched between 2 pieces of the same material, and it's always been an ability to measure single-sided, which is loosely, if configured on the room temperature sample holder, the sensor on top of insulation with your sample on top of that. That's always been a capability. We wanted to create a transient plane source sensor modified that is permanently assembled in an asymmetric or single-sided format, which is convenient, and add all the benefits of the transient plane source method following the ideal theory, so that you don't need a contact agent and you don't need calibration. So I invite you, in terms of construction of the sensor or seeing what sensors are made out of, is ask any maker of modified transient plane source to do the same. So if they can destruct it and show you that the basic principles are still insulation, sensor, and sample, it's just configured conveniently, following ideal theory, you don't need contact agent. And you still have all the strengths of varying test time, direct properties for thermal conductivity and thermal diffusivity, calculated specific heat. All that ideal theory applies. So it's a really strong capability we've added to this. So in addition to the MTPS sensor, we can offer an upgrade on the transient hot wire sensor. So the major upgrade is back pressure. So the sensor that's included with the MPV is ambient pressure, and this is one of our sensors we've pulled from our THWL series for measuring approaching boiling points or past boiling points. So the temperature upgrade on this is up to 100 degrees, but with the ability to measure with a back pressure, you can measure approaching boiling points depending on the temperature range of your fluid. Now, of course, if you need higher temperature than that, we offer a 300 degree version within the MP1 series and our THWL1. So we have the ability to go up to 300 degrees in cryogenic if your application needs. And of course, we have our transient line source. So this is following ASTM 5334 and 5930 for measuring soil and polymers. This is following ASTM 7896 for thermal conductivity, thermal diffusivity, and specific heat of liquids and phase change materials. There is a phase change material cell you can add to this, which accounts for volume change of a PCM or phase change material. And then you have the optional MTPS sensor to go up to 100 watts per Kelvin or 500 watts per Kelvin at 2 different temperature ranges of 100 and 200 degrees Celsius. That, no matter what, includes the bulk, slab, 1D, and anisotropic module, all asymmetric configured, as well as what we described previously on the MPV series. So I invite you, we will be doing demonstrations, technical demonstrations and measurements over this week and coming weeks, of course. We use the demonstration corner a lot to share technical information, because that's at the heart of what we do across multiple methods, both steady state and transient. So thank you for joining and learning about the Intelligent MP series, as well as the MPV, the new addition to the MP family. Thank you very much.